Hey guys, this is Mrs. Tran-Bloom. Hopefully you guys are doing well. We are towards the end, okay? So this is kind of the end of our chapter 6, which as you know, trig is such an important unit, especially chapter 6, because if you don't understand chapter 6, you're not going to do well in chapter 7 or chapter 8. So make sure you are listening to the videos, as well as if you have friends that keep keep asking you to copy the videos or the notes, tell them straight up, said, hey, go listen to the videos, go do your own stuff. Allowing friends to copy notes, it's really not helping them out. Okay, once in a while, I can see it. But honestly, if they do it all the time, then it gets old and you're really not doing them any favor. So tell your friend to go do their own stuff. Or just tell your friend that, hey, you know what? She's going to get mad at me, so I don't want to get in trouble. Okay, so that's how you avoid all of that stuff. But before I start, let's give you a toddler joke, all right? My toddler joke of the day is, how do deaf mathematicians communicate? So how do deaf mathematicians communicate? Deaf mathematicians communicate by sign language. Haha, sign language. You get it? Okay. Alright, that is my toddler joke of the day. I normally forget, so I just want to tell you right away so that way you can remember. Anyway, so we are starting with, or picking up where we left off. Last time we graphed the transformation of tangent and the transformation of secant. It says here, use key points to graph, state the domain and range, and determine the amplitude and period. So today we're going to do the last two on example 1. Okay, and looks like that will be the end of our day. So we have 2 things going on today. So here we go. Moving on up. Okay. So the first thing is we're going to find the amplitude and period. So period. Since cosecant is the reciprocal of sine, period will be very similar to sine. So 2 pi divided by absolute value of b. This is y equals 2 times cosecant of 1x. So your b is really 1. So 2 pi divided by 1, absolute value of 1 is really 2 pi. Okay. So it's going to repeat itself after 2 pi. So what I'm going to do is I'm going to graph out 2 pi on the right, negative 2 pi on the left, and I want to do 3 periods. So 2 pi is 1 period, so 4 pi is the second period. Now on the notes and on your test and everything else, I'm always going to ask you to do 2 full cycles. So technically you could do 1 on the right and 1 on the left, or you can do both on the right or both on the left. It doesn't really matter as long as you give me 2 full cycles, okay? The next thing it asked was to find the amplitude. Amplitude, and as you remember from the parent function of cosecant, there's none. Okay, there is none. Okay, so what we're going to do first is I'm going to give you the points, okay, for sine. So the parent function is y equals cosecant of x, and cosecant is really 1 over sine of x. So I'm going to make a chart here. Hopefully I have enough space. Here's output. And here is, I'm going to do sine of x. So y equals sine of x. Okay. So by now, you should know these values really, really well. All right. It's like the basic multiplication tables. You kind of have to, when I ask you what's 2 times 3, you have to spit it out like this. So if I ask you when x is 0, what's sine of 0? You should be able to spit out 0. When x is pi over 2. What's sine of pi over 2? You should be able to say 1, just as fast as I'm saying it. And when x is pi, I'm sorry, not, pi. Sine of pi is going to be 0. When x is 3 pi over 2, remember we need 5 inputs. Sine of 3 pi over 2 is negative 1. And when x is 2 pi, sine of 2 pi is back at 0. So that's the sine function. But remember, cosecant. So let's talk about this cosecant function, okay? I'm going to put, what I'm doing is I'm going to write y equals cosecant of x here. Trying to squeeze that in there. Can you see it? Alright, you know what I'm going to do? I'm just going to erase again, just to kind of make it neater. So y equals, here we go, y equals cosecant of x. Alright, and then I'm just going to his tick mark, 2 pi goes there. All right, there we go. So y equals cosecant of x. Let's zoom that in really quickly. I'm just going to focus on this piece. Well, cosecant is just really 1 divided by sine. So what happened when I do 1 divided by 0? That's really undefined. 1 divided by the output, which is 1, which is 1. 1 divided by 0 is undefined. 1 divided by negative 1 is negative 1. 1 divided by, thank you, hopefully you're saying undefined. Okay, so here are my inputs. Here are my outputs of cosecant. So anywhere that sine used to be 0, it just turns into undefined value for cosecant. And that's where I'm going to put my asymptote. Okay. All right, so every period has 4 full intervals. Okay, here we go. Okay. So if this is 2 pi, this is a pi, this is a pi over 2. Okay? So each tick mark is worth a pi over 2. Now you have a couple of transformations, so which I'm out of space on the left, so I'm just gonna do on the right. Okay, the first transformation is gonna be the 2 times cosecant of x. This is a vertical stretch factor of 2. Okay, oops, let me just zoom in a little bit because it doesn't look like you can see that. Oop, there you go. This minus 1 right here is a shift down of 1 unit. Okay. So you have 2 transformations. So what I'm going to do is I'm going to, since I'm out of space over here, I'm just going to make another table over here with both of these transformations right here. Oh, you know what? That's my husband. So what I'm going to do is I'm going to mute my husband really fast and call him back in about 20 minutes. Okay? All right. Sorry, husband. Okay, so here we go. I'm going to make another table just because I'm out of space on the left-hand side. Right? I'm going to put all the 5 inputs back. The inputs, they don't really change because there's no horizontal transformation here. So 0 pi over 2, pi, 3 pi over 2, and 2 pi. Okay. Now the outputs. The vertical stretch factor of 2 is going to change my output a little bit. So I'm going to have 2 times y. A vertical shift of 1 down. It's going to be subtract 1. So all of these outputs right here, I'm going to apply these transformations. Okay. 0 times 2 is going to be 0. Minus 1 is going to be minus 1. Oh, what am I doing? I'm sorry. Don't look at, ignore what I just said. This is my output. Asymptote is going to be an asymptote. Doesn't matter how much you stretch it. Okay, and even if you're moving it down by 1, it's still going to be an asymptote. So you have an asymptote at 0, which is here. Okay, so even if you stretch it out, you move it down, it's still the same exact line. The output is 1. 1 times 2 is 2. 2 minus 1 is going to be 1. The output is asymptote, and you do both of the 2 transformation, you're still going to have another asymptote, so that one's at pi. Okay, let me just plot this out. This is at 1. Okay. The asymptote is negative 1. I'm sorry, the output is negative 1. 2 times negative 1 is negative 2. Negative 2 minus 1 is going to be a negative 3 when the input is 3 pi over 2. So 3 pi over 2 is right here. Negative 1, negative 2, negative 3. There's my dot. My output is asymptote. Okay, so at 2 pi, look at this one over here. At 2 pi, my output is asymptote, and asymptote stretch or shifting down is still an asymptote. So I have an asymptote here. Okay. Do you remember what cosecant and secant look like? I only have 2 dots. Do you remember what it's supposed to look like? I hope you're saying U-shape. Okay, so this is a U-shape opening up. This is a U-shape opening down. So that is 1 full revolution. Okay. Now, because I want to do at least 2, I'm going to repeat another one on the right. So it looks like there's an asymptote pretty much at every pi. Okay. I have an up dot and a down dot, so now I know this is an up dot by repeating the pattern. Math is really just patterns, okay? And this is a down dot at -3. Repeat that pattern. Okay, so now I have 2 full revolutions, and I want to do another one on the left as well, just to show you that sometimes people can choose different interval to graph. This is an up, this is a down, this is an up, this is a down, so or down up, so this has to be a down. Okay. And then this is up at 1. All right. So that is 3 full cycles of y equals 2 cosecant of x minus 1. Now it also wants to know the domain and range. Okay, so the domain. Okay. Looks like the domain I'm excluding pi, 0, 2 pi, 3 pi, and 4 pi. So, but how would we write that out, right? So the first positive number is going to be pi. And it looks like I'm adding a pi each time. So pi plus another pi, 2 pi. 2 pi plus another one's 3 pi. So you can do a couple of things. You can say, hey, the domain is all real numbers excluding pi plus pi k. That is one of the choices. Or you can do, hey, the domain is when I multiply this by 1, I get 1. When I multiply by 2, I get 2, or 3, and 4. So you can do pi k. Okay? Pi k when k is any integer. Okay? Same thing for, oops, that is such an ugly wavy line. Same thing over here. K can be any integer as well. K is any int. Okay? So when k is 0, you will get a pi, which works. When k is 1, you will get 2 pi. That is where we're excluding. When k is -1, this will be a negative pi, and that would give me 0. So either one would work, okay? Oh yeah, can you just do this one? It's x cannot be. Thank you. So you have multiple ways of writing the same exact thing, and that's always okay in math, right? Your range. Alright, your range is really looking at the y. Looks like it's from -infinity to -3. Okay, so -infinity, non-inclusive, -3, inclusive. Alright? Or, which is represented by u, +1 to infinity. So inclusive at 1 all the way to infinity. So we have answered all the questions on direction example 1. Let's go and graph the last thing in example 1 or in 6.5. Similarly, we're going to look for the asymptote and amplitude. So let's get the easy stuff out of the way, okay? Amplitude, there is none, okay? No amplitude for tangent, cotangent, cosecant, and secant. So we'll box that up. Period, because cotangent is the reciprocal of tangent. It's just going to be pi divided by absolute value of b. Okay, so this looks like a pi right there. This is read y equals 2 times cotangent of a -1/2 x minus 2. So pi, your absolute value of b. B happens to be -1/2. Okay, so absolute value is going to be a +1/2. Dividing by 1/2 is going to be the same as multiplying by 2/1. So your period is 2 pi. Okay. Remember, the normal period for a parent function is going to be a pi. So this is a stretch, a horizontal stretch by 2 pi. So 2 pi, I don't want to do 2 full cycles, so now 4 pi. If I want to go left, it would be a -2 pi. Okay. So you know what I'm going to do? I'm going to use the right hand side space here because there's a little bit more room to work with. All right. Y and x and then y equals cotangent of x. This is just the parent function, okay? My 5 inputs is 0, pi over 4, pi over 2, 3 pi over 4, and pi. And remember, we end at 5 is because for cotangent and tangent, the period ends at pi. So let's just do the parent function first, and then we're going to talk about the 1, 2, 3, 4 different transformations that we have to work with. So cotangent at 0, cotangent at 0, here we go, 1 comma 0, right? Cotangent is x divided by y. So 1 divided by 0 is going to be undefined. Cotangent of pi over 4, which is this dot, cotangent pi over 4 is rad 2. I'm sorry, what am I saying? I'm thinking about sine over and cosine. Cotangent pi over 4 is 1, which is a lot nicer. Cotangent at pi over 2, x divided by y. So x is 0, y is 1, so 0 divided by 1 is 0. Cotangent through pi over 4, which is this dot right here, that's going to be a negative 1. And back at pi, which is also back at being undefined. Okay, so this is the parent. These are the inputs and output for your parent. Okay, now let's talk about all the transformations that we have to do. Your transformation, the first one, I'm always going to go from left to right. The first one is going to be a vertical stretch factor of 2. This minus sign right here is going to be a reflection about the y-axis. Okay, this 1/2, notice how when we divided pi by 1/2, it made it larger, so it's actually a horizontal stretch factor of 2 as well. And when it's a stretch, it has to be of a scale greater than 1. You can't really say, hey, things are stretching by 1/2. That doesn't really make sense, okay? And this is going to be a down by 2. Looks like I love number 2 in this problem. All right, so I'm going to use all of these and then do the transformation for here. Now, which one is going to be the x change? We have a vertical stretch, that's y. Reflection about the y-axis. That means whatever is on the right-hand side, it has to be on the left. So that's really an x change, right? So minus x, or multiplied x by negative 1. Horizontal stretch factor of 2. Actually, I'm just going to multiply by negative 2. Okay, like that. That's my x change. Now, the down by 2 is going to be a y change. Okay, so I took care of that, and I took care of that. And now vertical stretch factor of 2, so that's 2y minus 2. So that's my y changes, and this is my x changes. All right, my inputs are 0, so 0 times negative 2 is still 0. Pi over 4 times negative 2 is now a negative 2 pi over 4, which reduces down to negative pi over 2. Pi over 2 times a negative 2 is going to be now a negative 2 over 2, which is reduces down to negative pi. Now, if you look at the pattern, which is mathematics, from here to here, I'm subtracting pi over 2, and then if I subtract another pi over 2, I'm going to get to negative pi. So if I subtract another pi over 2, I bet you anything I'm going to end up with 3 pi over 2, negative. Okay? And then if I subtract another one, I'm going to end up with negative 2 pi. And we can verify that. So pi times negative 2, which is my last input, which is negative 2 pi. 3 pi over 4 times negative 2 is going to be a negative 6 pi over 4, which reduces down to negative 3 pi over 2. So if you look at the pattern, it's going to be the same as if you were to multiply. Okay. Now the outputs. Asymptote, okay, stretching it by 2 is going to be the same. And shifting it down by 2 is still going to be the same. So that's still going to be an asymptote, okay, at 0. There you go. You know what I should do? I should make 4 equal intervals here. Okay. That's my first asymptote. Check. Okay. Now, negative pi over 2, which is my next one. My next output is 1. 1 times 2 is 2. 2 minus 2 is 0. So I'm going to call it dot at negative pi over 2, comma 0. Right there. Next, 0 times 2 is going to be 0. Minus 2 is going to be negative 2. So next tick mark over, negative 1, negative 2, right there. Next one, negative 1 times 2 is going to be negative 2. Negative 2 minus 2 is going to be negative 4. So 1, 2, 3, and 4. So over negative 4. And this output, asymptote, stretch it by 2 is still an asymptote line. Shifting it, moving down by 2 is still going to be an asymptote. So that's going to be an asymptote still. All right, see, look at that. Okay, so remember sine and cosine. It looks like a wavelength. Cosecant and secant, they look like U's. Cotangent and tangent, they look like lazy S, okay, shape. And this looks more like a tangent, but cotangent is supposed to be the other way around. The reason is that because this is a reflection about the x-axis, so now it looks more like tangent. Now, what's the pattern? It looks like I have an asymptote every 2 pi, right? So here we go. An asymptote here, and then every 2 pi, there's an asymptote. So, looks like 1 tick mark away from my right asymptote, it's a dot at 0. 2 tick mark away is going to be a dot at -2. 3 tick marks away is going to be a dot at -4. So those are my 3 dots. You're going to need 3 dots for tangent and cotangent. Okay. Similarly, 1 tick mark away is going to be at 0. 2 tick marks away is going to be at -2. 3 tick marks away is going to be at -4. So those are 3 dots, and I'm just going to connect. All right. Aren't those beautiful? Okay, so let's talk about the domain and the range. Now, the range looks really easy. The range is going to be all reals, or aka from -infinity to infinity. So we're just going to box that up. Now, the domain, what are we excluding? Okay, because anytime you have asymptote, we're going to exclude. We're going to say, hey, all reals excluding. I have 1 at 0, 1 at 2, 1 at 4. So technically, it looks like I can multiply by 2, right? So we can exclude 2 pi k, where k is any integer. Okay, that's one option that what we can write. Another one we can write is I can add 2 each time. Okay, so and again, you don't have on the test, on the homework, you don't have to write both of these, but I'm just showing you in the notes that what options you can use. 2 pi, if I add 2, I'm going to get 4. Okay, so I'm going to go, hey, 2 pi k. Would you agree that's okay too? Sure. Where k is any integer. So let's test it out. When k is 0. 0 times 2 pi is 0. 0 plus 2 pi is 2 pi. I do have one. When k is -1. -1 times 2 pi is -2 pi. Plus 2 pi is 0. I do have an asymptote here. When k is 2, 2 times 2 pi is 4 pi. 4 pi plus 2 is 6. So I'm probably going to have another one over here if I keep on going. So as you can see, it works. Okay, so you have a lot of options when you're writing your domain or the exclusion of the domain. Okay, all right, looks like this is the end of 6.5. Until next time, bye-bye.